Okay, we're back here on lunar eclipses. When we take a look here, here's a good way to take a look when we're dealing with the lunar eclipse here, is that we have two different shadows produced from the light source um, that shines on the object, and those two shadows are produced, as you can see here on the drawing that we find, is that you can see the shadows produced right here. The first one, the darkest one, is the umbra. It's a zone of full shadow that we find. Then the larger area that we have here is the penumbra. It's a zone of partial shadow that we see. The umbra is what we need to get a total eclipse of both a lunar eclipse and a solar eclipse. And the penumbra is when we get a partial. And during a lunar eclipse, what happens is that the moon falls within the umbra of the Earth during a total lunar eclipse. During a partial lunar eclipse, the moon falls within the penumbra that is produced from the shadow of the Earth that we see. So, all right, now, taking a look here with the lunar eclipses that we find, and we take a look here, you can see here, here's the Earth, here's the shadow that's produced here, there's the umbra that's produced, and you can see how much larger the penumbra is. And what happens is that as the moon within its orbit moves within these shadows, we start with a partial, then we go to a total, and then it starts to move back. And these take they can take quite a while in the evening. It can last for a couple hours in the evening sky, and you'll see a chart there that will, at the end of this, will explain how long they actually are. And if we take a look here with this as well, is that we see as the path comes through here, you can see how it passes through the penumbra, and you can see how that matches up here with everything. And then once you reach that point of totality, once you're getting there in the center of the umbra, that's when you have the atmosphere on Earth, the light shining through the upper levels of the atmosphere. It turns, it bends, shortest wavelength is going to be red, and that will cast that reddish glow onto the moon that we see. And you can see what happens is that partial, it goes eclipse, and then it right there in the center is when you get that blood red, which is really cool to watch. But again, these take a while to watch in the evening, which is totally different from a solar eclipse that I'll explain a little bit in the next video. And if you take a look here, the total part of the lunar eclipse, the totality can last roughly about an hour and 40 minutes. And the partial can last hours before and hours after. So that's what we find with these, and also with the lunar eclipse. You don't have to worry about safety with your eyes going out and watching it, because you don't have to worry about the radiation from the sun, and I'll explain that when I talk about solar eclipses in the next video. And you can see here when we have these different eclipses that are going to be taking place, and if you take a look here in October of 2014 as our next one is coming up, I can guarantee you will probably be cloudy that night and we won't be able to see it. So, alright, well, we'll stop the video here. The next one we're going to talk about solar eclipses.